Welcome to The Explainer. Today, we are diving deep into the architecture of the Databricks Data Intelligence Platform. We're going to see exactly how it's built to bring data, analytics, and AI all under one roof.
So, here's our game plan. We're going to start with a problem that I'm sure a lot of you have run into. Then we'll look at the big idea that solves it, get into the nitty-gritty tech, and finally, see how it all comes together for real-world teams.
Okay, let's get right into it. To really get why Databricks is designed the way it is, you first have to understand this fundamental tug-of-war that has been going on in the data world for years.
For the longest time, if you were dealing with data at scale, you were forced into a really tough choice. You had to pick between two very different paths, the data lake or the data warehouse. And honestly, neither one was perfect. It felt like you had to pick your poison.
On one side, you've got the data lake. It's like the Wild West. Super flexible, you can just dump any kind of data in there, structured, unstructured, it doesn't matter. And it's pretty cheap. But, and this is a big but, that freedom often leads to chaos. It can turn into a data swamp where you just can't trust anything. Then on the other side, you have the data warehouse. It's clean, it's organized, it's incredibly reliable for your business reports, but it's also really rigid, super expensive, and just wasn't built to handle the messy, diverse data you need for things like modern AI.
So this is the big question, right? What if you didn't have to choose? What if you could have the best of both? Well, that exact question is what led to the core concept behind the whole Databricks platform.
And the answer is the Lakehouse. Now, this isn't just a simple compromise. It is a fundamentally new type of architecture. The whole point is to give you one single platform that has all the low-cost, flexible storage of a data lake, but with the performance, the reliability, and the governance you'd expect from a top-tier data warehouse.
That sounds amazing in theory, right? But how does Databricks actually pull this off? Well, the whole thing stands on three incredibly important technical pillars that all work together.
Yep, these three pillars, think governance, storage, and compute, are the magic that lets everyone, from your engineers to your data scientists, work from the exact same data. So let's break down the first one.
So pillar number one is all about control. It's called Unity Catalog. The best way to think about it is as the central brain for your entire data universe. It governs literally everything, not just your data tables, but your ML models, your files, your dashboards. It's the one place you go to set permissions, to audit who's accessing what, and to see the lineage of your data. This is absolutely massive for security and just for knowing what's going on.
Okay, pillar number two brings that bulletproof reliability of a warehouse to your data lake. This is Delta Lake. It's an open source storage layer that you put right on top of your existing cloud storage. And its secret sauce is something called ACID transactions. Now that's a technical term, but all it really means is that when you write data, it either all succeeds or it all fails. A job can't fail halfway through and leave your data corrupted. It also gives you this incredible feature called time travel, where you can literally rewind your data to a previous version. It's a total lifesaver. And the third pillar? Well, this one is all about pure, unadulterated speed. Databricks is built on Apache Spark, which is the industry standard for big data processing. But their real game changer is an engine called Photon. It was built from scratch in C++ for maximum performance. Think of it like a Formula One engine for your data. It processes data in big chunks instead of row by row, which makes your SQL queries and other data work just fly.
And this table right here just makes it so clear. Look at a standard data lake on the right. Can it guarantee a write won't get corrupted? Nope. Can you look at old versions of data? Not without a ton of manual work. It's rigid. But now look at Delta Lake on the left. You get those bulletproof ACID transactions. You get time travel built right in. Your schema can evolve. It even has smart features like liquid clustering to keep things fast automatically. It's a night and day difference.
Okay, so we've seen the core building blocks. Now let's zoom out a bit and look at how the platform is actually structured from an operational standpoint. It's a really clever design that separates the management from the actual work.
The easiest way to think about it is the brain versus the muscle. The control plane is the brain. It's run completely by Databricks in their own cloud.
It handles the web interface, your notebooks, scheduling jobs, all that management stuff. But, and this is key, your actual data doesn't live there. The data plane is the muscle. This is where all the heavy lifting happens, where your code actually runs and processes your data. And this is where you get a really interesting choice for how you set up that muscle. With the classic model, the compute clusters, the things doing the work, are running inside your own cloud account, so you have full control over the networking and security. But then there's the serverless model. With this, you give up some of that fine-grained control for pure convenience. Databricks manages all the compute for you, so you get instant-on performance without ever having to worry about managing servers. It's really a choice between total control and total simplicity.
So we've gone through all this tech, but what does it all mean? What does this unified architecture actually do for the people who have to use it every single day? Because that's the real bottom line.
Well, what it means is that for the first time, pretty much ever, all of your data people can work together on the exact same copy of the data. Your data engineers are building pipelines, and the second that data lands, your data scientists are building models on it, and at the same time, your data analysts are querying it for their dashboards. There's no more shipping data back and forth between systems, no more waiting. Those data silos that cause so many problems, they're just gone.
And that's really what it all comes down to. This whole architecture is designed to shift your team's focus. Instead of wasting all their time and energy managing a complicated mess of different tools and pipelines, they can focus on what they were hired to do. Find insights, build amazing things, and solve the really tough problems for your business.